Buckle up, everyone, because today we're taking a deep dive into a world where math and art collide, a world of infinite complexity and mesmerizing beauty. We're talking fractals.
Ah, fractals. They're more than just pretty pictures. They're a key to understanding the intricate patterns woven into the fabric of our universe.
Okay, so for anyone who's not familiar with these crazy intricate shapes, can you give us a fractal 101?
Sure, think about a tree. The way it branches out, each branch is like a mini version of the whole tree. And those branches have smaller branches and so on. It's a pattern repeating itself at different scales. That's self-similarity, and it's a defining feature of fractals.
So it's like those Russian nesting dolls, but with patterns instead of dolls.
Exactly.
Okay, so that's in nature, but we see fractals in math too, right? I remember seeing these wild computer-generated images of fractals back in high school.
Right, those images are visual representations of mathematical equations. And what's amazing is that these equations can generate infinite complexity from relatively simple rules.
So a simple formula can create something that looks incredibly intricate and detailed.
Precisely. It's like the universe is saying, hey, I can create incredible beauty and complexity with just a few basic ingredients.
That's mind-blowing. But how do fractals, differ from the regular shapes we learn about in geometry, like squares and circles and all that?
That's Euclidean geometry. It's great for describing man-made objects, but nature is much more complex than that.
Right. Nature doesn't really do straight lines.
Exactly. Fractals allow us to describe that complexity, the curves and irregularities that make nature so fascinating.
So it's like Euclidean geometry is like the blueprint for a building, while fractals are the blueprint for a forest.
A great analogy.
Okay, so fractals are basically like nature's geometry. But what about those fractal dimensions we hear about? They always sounded kind of mysterious to me.
Well, in Euclidean geometry, we deal with whole number dimensions. A line is one-dimensional, a square is two-dimensional, a cube is three-dimensional.
Yeah, I remember that from school.
But fractals can have dimensions that fall between whole numbers.
Wait, dimensions between numbers? How's that even possible?
Think of a coastline. It's more than a line, but not quite a two-dimensional surface. It's somewhere in between, and that's where fractal dimensions come in.
So the more jagged and twisty a coastline, the higher its fractal dimension.
Exactly. It's a measure of its complexity.
Wow, that's like a whole new way of measuring the world.
And this concept of fractal dimension isn't just theoretical. Scientists use it to study everything from the roughness of surfaces to the complexity of brain activity.
So we're talking about a whole new way of measuring and understanding the very fabric of reality.
Absolutely.
That's incredible. Now, I can't talk about fractals without mentioning the rock star of the fractal world, the Mandelbrot set.
Ah, yes, the Mandelbrot set. It's a visual masterpiece and a mathematical marvel.
I've seen pictures, and it's just this infinite swirl of colors and shapes. It's mesmerizing.
And what's amazing is that this incredible complexity is generated from a surprisingly simple equation.
Wait, so behind all that visual chaos, there's just a simple formula at work.
Yep, it's a testament to the power of simple rules to generate incredible complexity.
Mind blown again. So we can zoom into the Mandelbrot set forever, and we'll keep finding smaller Mandelbrot sets inside.
Exactly. It's like a universe within a universe, an endless journey into the heart of complexity.
That's so cool. But beyond the wow factor, how do fractals actually show up in our everyday lives?
Well, for starters, take a deep breath.
Okay, inhales.
The way your lungs branch out, that's a fractal pattern.
Really? So my lungs are like little fractal trees?
You could say that. That branching pattern allows for a huge surface area for gas exchange, making your lungs incredibly efficient.
Wow, so fractals are helping me breathe right now.
They are. And speaking of nature's efficiency, have you ever noticed how lightning never travels in a straight line?
Yeah, it's always zigzagging all over the place.
That's because it's following a fractal path. That shape allows it to distribute energy most efficiently.
So lightning is basically nature's electrical fractal.
Pretty much. And we've actually harnessed that principle to create fractal antennas.
Fractal antennas.
Yeah, you'll find them in everything from cell phones to satellites. Their compact fractal design makes them incredibly efficient at transmitting and receiving signals.
So we're using the power of lightning, or at least the principles behind it, to make our technology better.
Exactly.
That's amazing. It's the more we learn about fractals, the more we realize just how fundamental they are to everything.
They really are a key to understanding the universe, and that's what makes them so fascinating.
I'm hooked. So where do we go from here on this fractal journey?
Well, next we're going to delve into how fractals can help us understand seemingly random and chaotic systems. things like the stock market and weather patterns.
Okay, now that sounds like a challenge. But if fractals can help us make sense of that, I'm all ears.
Get ready for another mind-bending ride.
All right, so we've covered how fractals help us see the hidden patterns in nature, from our lungs to lightning strikes. But you mentioned that they can also shed light on, like, unpredictable things, like the stock market or even the weather. That seems kind of, I don't know, counterintuitive, doesn't it?
It might seem that way at first, but that's where the true power of fractals comes into play. Think about it. For centuries, scientists have been baffled by things like weather patterns, or the stock market, because they just seem so random and unpredictable.
Yeah, I mean, I can't even trust the weather app to tell me if I need an umbrella tomorrow, let alone predict the stock market.
Exactly. It all seems like it's governed by pure chance.
Hmm.
But what if there's an underlying order hidden within that apparent chaos? That's what fractals can reveal to us. They show us that what seems random on the surface often follows a set of rules, just a really, really complex set of rules.
So you're saying, like, it's not truly random, it's just that the patterns are so intricate that our brains can't really grasp them?
Precisely. It's like when you look at a tapestry up close, all you see are these individual threads, seemingly unconnected. But when you step back and view the entire tapestry, you see this incredible, intricate pattern forming a beautiful picture. Fractals are kind of like that. They help us step back from the chaos and see the bigger picture.
Oh, I like that analogy. Okay, so how does this work with something like the weather? It's not like there's a giant fractal equation out there controlling the clouds, is there?
Well, not a single equation, but there are underlying patterns that shape how weather systems develop. Think about how a storm cloud forms. You have this small disturbance, then it grows and branches out, creating smaller storms within the larger one. That branching pattern, that self-similarity across different scales, that's a signature of fractals.
So even a thunderstorm, which always seems so unpredictable, could have this hidden fractal order to it. That's wild.
Exactly. And we see this in other systems that seem chaotic too, like the stock market, for example. It might feel like stock prices just jump around randomly. But if you look at the data through a fractal lens, you start to notice patterns emerging. You have these cycles of booms and busts that repeat themselves at different time scales, from daily fluctuations to long-term trends.
So instead of trying to predict, which stock is going to go up or down tomorrow, maybe we should be focusing on these larger fractal-like patterns in the market.
That's exactly what some traders and analysts are doing. They're using fractal analysis to identify trends and potential turning points in the market. It's not about finding a magic formula, but about getting a deeper understanding of how these complex systems actually work.
Wow, this is really making me rethink how I see the world. It's like everything is connected by these hidden patterns, these echoes of order within the seeming chaos. And speaking of big picture stuff, we touched on dark matter earlier. Can you tell me more about how fractals are connected to that?
Ah, dark matter, the biggest mystery in the universe. It's the invisible stuff that makes up most of the universe's mass, but we can't actually see it directly. We only know it's there because of how its gravity affects the stuff we can see.
Right, like how galaxies are spinning faster than they should if we only count the matter we can see. So where do fractals fit into all of this?
Some physicists think that the way dark matter is spread out in the universe might follow a fractal pattern. Think about it, just like galaxies are grouped together in clusters, those clusters could be grouped into even larger clusters and so on, creating this vast cosmic web that stretches across incredible distances.
Wait, so you're saying that the invisible scaffolding of the universe, the dark matter that holds everything together, might be built on these repeating fractal patterns?
That's one of the leading theories. And by studying these patterns, we might be able to learn something about the nature of dark matter itself, and how it shaped the universe. Remember, the early universe, just after the Big Bang, was this incredibly hot and dense place. As it expanded and cooled down, tiny fluctuations in this, like primordial soup, started to grow, eventually forming the stars and galaxies we see today.
Okay, so are you saying that those initial fluctuations, those seeds of structure, they might have been fractal in nature, and that somehow influenced how the universe evolved over billions of years?
Exactly. It's a mind-boggling idea, but it really highlights how these principles of self-similarity and repetition, the core of fractals, can shape even the largest structures in the universe. But let's shift gears a bit, from the vastness of the cosmos to the inner workings of our own minds. Remember how we talked about fractal patterns in our brains earlier?
Yeah, like how our brains are these incredibly complex networks.
Well, some scientists think that those fractal patterns might hold the key to understand something even more profound: consciousness.
Hold on consciousness. You're telling me that these fractal patterns, the same ones we see in like trees and coastlines, could be connected to our ability to think and feel, to like experience the world.
It's definitely a bold hypothesis. Think about it. Our brains are these massively complex networks, billions of neurons firing and connecting, a symphony of electrical activity. And those networks exhibit self-similarity at different scales, just like fractals.
So the way our neurons are wired together, the very foundation of our thoughts and feelings, that could be mirroring the same patterns we see in nature, from snowflakes to galaxies.
That's the idea. And if it's true, it raises some pretty deep questions about the nature of consciousness itself. Could it be that consciousness emerges from this fractal-like organization of information in the brain?
Whoa, now we're getting into some really deep philosophical territory. If these patterns are so fundamental, does that mean consciousness is more widespread than we realize? Like, could it be a property of any complex system that exhibits these fractal patterns?
You're asking some fascinating questions. These are things philosophers and scientists have been pondering for centuries. But the fact that we can even ask these questions, and we're starting to see these connections between the patterns in nature and the mysteries of our own minds, it just goes to show how powerful fractals are in changing how we understand the world and our place in it.
It's like fractals are giving us this new language, a new way to look at reality, And this new perspective is opening up possibilities we couldn't even imagine before. But aside from these mind-blowing implications for consciousness and the universe, what about, the practical stuff? You mentioned something about fractal medicine earlier. What's that all about?
Well, it turns out that a lot of biological processes, things like your heartbeat or how cells grow, even the way diseases spread, they all exhibit fractal patterns. By analyzing those patterns, doctors can learn a lot about how our bodies function and how diseases develop.
So it's like doctors are using fractals to crack the code of our bodies, looking for subtle clues that could point to health issues or potential diseases.
Exactly. Take cancer, for instance. Researchers are looking into how fractal analysis could be used to detect cancer in its early stages by identifying irregularities in how tumors grow. Cancer cells tend to grow and divide in a chaotic, fractal-like way, so by studying those patterns, doctors might be able to spot tumors before they become detectable through traditional imaging.
That's incredible. It's like fractals are giving us a whole new toolkit for diagnosing and treating diseases, and I bet this fractal perspective could be applied to other areas of medicine as well.
Absolutely. Researchers are using fractal analysis to study all sorts of things: heart rhythms, brain activity, bone density. The possibilities seem endless, and we're only just scratching the surface of what we can do with it. And as we learn more about fractals, I'm sure we'll see even more innovative applications in other fields too.
Wow, so it's clear that fractals are way more than just mathematical curiosities or pretty pictures. They're this powerful tool for understanding ourselves and the world around us.
Precisely. They're a key to unlocking that hidden order within what seems chaotic, this bridge between the vastness of the cosmos and the intricacies of our own minds.
This has been an incredible journey so far. I feel like my mind has been totally blown wide open. So what's next on our fractal adventure?
Next, we're going to explore something that might be the most mind-blowing yet.
Yeah.
The connection between fractals and the quantum world.
Okay, quantum mechanics is already pretty mind-bending on its own. Throw fractals into the mix, and I can only imagine what kind of wild ride we're in for. Lead the way. All right, so we've traveled from the largest structures in the universe down to the tiny patterns in our own bodies and minds. And now we're diving headfirst into the quantum realm. I have to say, the combination of quantum mechanics and fractals, well, it's definitely piquing my curiosity.
Well, hold on tight, because this is where things get really weird, even weirder than usual. For a long time, classical physics, the physics of our everyday world, and quantum mechanics, the physics of the very small, they seemed like completely separate worlds.
Right, like trying to mix oil and water. On one hand, you have the predictable world of, like, Newton and gravity, and on the other, you have this fuzzy, uncertain world of quantum particles.
Exactly. But fractals, they might just hold the key to bridging that gap. When physicists started really digging deep into certain quantum systems, they found something really surprising: self-similar patterns repeating at different scales, just like the fractals we've been talking about.
Wait, hold on. So you're telling me there's a connection between, like, the vastness of the cosmos and the subatomic world of quantum mechanics, that these two seemingly totally different realms might actually be speaking the same language, the language of fractals?
It's a pretty wild idea, isn't it? It suggests that fractals might be this like unifying principle that governs everything from galaxies to electrons, this hidden code connecting the macro and the micro.
So instead of two separate rule books, one for the big stuff and one for the small stuff, maybe there's actually just one set of rules, one underlying principle that plays out in different ways depending on what scale we're looking at.
Whoa. And this connection between fractals and quantum mechanics could have some pretty big implications for how we understand the universe as a whole. For example, there's this idea that even the Big Bang, the very beginning of everything, might have unfolded according to fractal principles.
Hold on, you're saying that the birth of the universe, that very first moment, could have been shaped by these same patterns we see in, like, snowflakes and coastlines, that the universe was basically born fractal.
It might sound crazy, but it could help explain why the universe looks the way it does today. You know, how galaxies are organized in these massive webs that stretch across billions of light years.
Right. It's not like galaxies are just scattered randomly throughout space. There's a definite structure, a pattern to how they're arranged.
Exactly. And those patterns could be a reflection of the fractal nature of the very early universe. Imagine the Big Bang as this tiny seed containing the potential for everything. As it expanded and cooled, those initial fractal patterns, those tiny fluctuations in energy, they would have grown and evolved, shaping the universe as we know it.
It's like the universe is this giant, constantly evolving fractal, always unfolding and revealing new layers of complexity. But if fractals are really that fundamental, so deeply woven into the fabric of reality, what does that mean for us? How can we actually use this knowledge in our own lives?
Well, for starters, it gives us this whole new way of seeing, a new way of thinking about the world. It encourages us to look beyond the surface, to see the interconnectedness of everything, instead of trying to force the world into these neat little categories. Fractals remind us to embrace the complexity, the chaos, the infinite variety that makes life so interesting.
So it's more than just a shift in perspective. It's like a whole new way of being in the world, recognizing those repeating patterns, that underlying beauty at every level, from the tiniest atom to the largest galaxy.
Exactly. And as we learn more about fractals, we're bound to discover even more amazing things about how we live, how we create, how we interact with the world. Take fractal-inspired design, for example. By copying nature's fractal patterns, we can create things that are more efficient, more resilient, more in harmony with the world around us.
You know, it's funny, we started this deep dive talking about how fractals, like, break the rules of traditional geometry. But in a way, they're also a return to a much older way of seeing the world. Finding the sacred in the patterns of nature, acknowledging the interconnectedness of everything.
That's a beautiful way to put it. Fractals remind us that the universe is way more complex and incredible than we can ever fully grasp. But by understanding their principles, by seeing the world through this fractal lens, we can begin to glimpse the beauty and the potential that's hidden within everything.
This deep dive has been mind-blowing, to say the least. I feel like my brain has been stretched in ways I never imagined. So to our listeners, next time you look at a tree, a cloud, the veins on your hand, remember you're looking at a fractal. You're looking at this incredible glimpse into the infinite complexity and beauty of the universe. Keep exploring, keep asking questions, and never stop being amazed by the world around you.